Hi, everybody. I just wanted to come on screen. I understand there's been some networking issues why we had to cut the last session short. So I do apologize for that. And I understand during the networking, there were also technical issues as well. So I just wanted to come on and apologize and thank everybody for hanging in there with us. I'm now going to hand over to Paul, who's going to introduce Amir Mahmoudkhani, who is going to have a discussion on paraffin.
Well, hi, everybody. Thanks again for hanging in there. I think we're overcome these technical issues now, but let's see what happens. So I want to introduce Amir Mahmoudkhani, Director of Technology at Lucas Bio Energy Solutions. Amir received his PhD in Materials Chemistry from Gothenburg University in Sweden. And after a year of postdoctoral work in Brookhouse Institute of Materials Science in Macalester University, Hamilton, Ontario, Canada, he started his professional career in Calgary, Alberta. He's been working for 20 years in various technical roles, including R&D, application development, project management, and is a member of the Industry Joint Research Programs, or JIPS. Amir was Clariant's Global Innovation Manager from 2014 to 17 and Global Head of Flow Assurance from 2018 to 2019, leading all technical activities for paraffin wax, asphaltene, and gas hydrate control. Before Amir joined Lucas Bioenergy in May 2019 as the Director of Technology. In his current role, he is responsible to lead and coordinate all major projects for new and novel bio-based materials for oilfield technologies from the reservoir to refinery applications. So I'll hand it over to Amir now to deliver his presentation. And remember, please ask questions in the Q&A section through Amir's talk. So if you have any questions, we can get them addressed at the end of the session. Over to you, Amir.
Thank you very much, Paul, for the nice introduction. Let me turn off my video because this makes it easier for me to handle that. I'm going to go back and share my screen for the slides, and I hope everybody can see my screen now.
Yes, you can see the screen now.
Excellent. So what I'm going to talk today is mostly about the paraffin wax, and I think it's one of my very I think specific interests. And I want to talk to you about the old problem, actually still looking for the new solution, right? So again, this is a case that we probably know. This has been around for about 100 years now. And if you look at what I like to see is that looking back into the history of SPE papers, the one I found is in 1927 and 1932. That 178 pages in a type of document is very much states the problem exactly the way that if you look at it, you think, well, it's just like right now. We still have same issues. We still have depositing, the organic depositing, either downhole in the tubings and rods, and of course the surface facilities and such and such. So nothing seems like has changed. This is still there, right? And of course, this has been, of course, a lot of attention for the industry. And I think this was during the 1960s that people started to think about, maybe I can find a chemical solution for that. And I think that was the time that this pioneering work by these two companies, the NJ Chemical Company, which turned to Exxon Chemical later, and as well as that work from the University of Texas in Austin, actually depicted the use of the polymers for the first time to be used as a paraffin controlled additive, right? So what we do, the state of art, as the current exact situation as we are, we have now, I think, multiple options to do the paraffin wax control. We can think about, some prevention methods. This could be anything from mechanical to chemical. And of course, there's a huge list of industry current practice to do that part. Sometimes, of course, we don't do much. We wait until the problem shows up itself. And in that case, we go after remediation. We still do, a lot of mechanical work, and we still use also a lot of chemistries, either as a solvents or dispersant and such, right? And of course, we are a lot of familiar with those pictures which are shown in here. You know, you always see some form of pigging going on. And of course, hot oilers are still used across the United States and as well as Canada and other places around the world. Some people tend to use, some form of a coating to prevent the wax depositing on the surfaces. And of course, a lot of chemicals, that you can find in any backyard, which is used as a chemical management control, right? Now, if you are in this market, and of course, if you are using some form of a chemical treatment, with no doubt that you're using some of these, 6 type of chemistries. And I can tell you probably, 90% of the chances that whatever chemistry that chemical product you're using contains one of these polymers or more, right? And of course, EVAs is one of the first ones which pioneered in terms of, controlling the wax, right? Now, of course, a lot of other chemistries, definitely surfactants play a key role in here. From 1970s, we started to use some anionic surfactants to, disperse the wax. And of course, later on, we went to more complex type of surfactants as well as some of the copolymers as a wax dispersants. And of course, the solvent has been always there, either some form of aromatic or paraffinic or the combination of the all, to do, right? So if you are in that area, in that case, what we're looking at, you're probably already paying somewhere between $6 to $30 per gallon for that type of chemistries to be used, right? Now, if you're looking at the typical chemical structures of those Vax inhibitors and what they call it sometimes, PPDs, or, then that's kind of very generic terms which are interchangeably used. You're looking at some form of the polymeric structures which are depicted in here. And let me see here, you can have either a star shape, you can have kind of a cone shape, and even multi-type of, branched type of polymers, right? And of course, the whole idea and the mechanism that everybody is talking to is that these polymers somehow can interact and co-crystallize with the wax crystals and somehow deform them or change them somehow that they don't agglomerate anymore or they don't form larger the solids that they can deposit, right? That's pretty much it, and then of course the function of that would be you changing. We don't stop actually precipitating the wax, but what we do is that changing the morphology of the wax crystals so that they still can be carried over, and as long as they don't deposit, that's what all we wanted to have, right? Well, of course, what we typically do as a general practice in the industry still is that we collect some field samples. We do a lot of lab screenings. Of course, we do some form of a deposition testing, or maybe the solvency type of testing. We do select the products, and then go for a field trial and do some optimization and qualification, things like that, right? In general, so far, what we have been using on a chemical treatment pack, either we do sort of a batch treatment, or we do a semi-batch, or sometimes we do a continuous injection. Of course, that kind of comes back to the success of this whole program. Which one is going to be the best? Of course, there are tons of factors which is impacting the success of that thing, right? But that's kind of a general practice. If you're doing a continuous injection rate, you're looking at somewhere between 100 ppm to 2,000 ppm based on the produced oil volume, right? And if you're doing, of course, a batch treatment, that very much varies. If you're dealing with the pipes, if you're looking at the tubings downhole, and if you're like, dealing with the tanks, things like that, of course, that could be a different, multiple levels of volumes of the products or the solvents that you use, right? Again, as I said, costs around $6 to $30 per gallon, kind of a nominal things. But if you look at the global type of market for chemical treatment for the wax, you're looking at somewhere estimated around $400 million per year and per annual base. So it's actually a huge market. It's not only dedicated to what's happening in US. Actually, a lot of other places, they have the same issue, right? Great. So this is, I think, the state of the art of the industry. This is what we're practicing. But is your chemical treatment good enough? Do you see, you're still applying those chemistries and still seeing this type of deposition, which I have some pictures over here, yes or no, right? Well, if it is, the answer is yes. There's not enough, for what you're doing. Definitely you're probably like myself thinking about what is causing that, why, and how we can mitigate that issues, right? And that's what I'm going to talk about from this point on, right? Now, to go to that, dive into that area, I wanted to point you to, really what we're dealing with is that really understanding the complexity of the crude oil. Most of the time, when I talk to, the clients, of course, the first thing that they talk about is API gravity, which is a good thing, not in nature. But what is lacking is actually what we wanted to understand from somebody who's coming from the chemistry, chemistry world. We're looking at what are the components of the crude, and particularly what we are more interested in is that what type of saturates, are present in the crude oil, right? And again, to be more specific, we're looking at, linear form or kind of a branch type of saturated alkanes, or sometimes, of course, we're talking about the cycloalkanes, right, with the complexity. It can get even more complex because we know the saturates are not the only components in the crude. There are also naphthenic type of naphthenes in the crude oil. There could be, of course, the asphaltenes and all the other components in that case. You get variations of the chemistry that you need to do, okay? Great. Now, one of the interesting things, I guess, happened probably within the last 5 to 10 years that people start paying attention to not the composition of what we are measuring on the crude oil sample that we're collecting. We also paid attention more into what is actually depositing in the field, right? And these are some of the examples that we did. This has actually appeared in one of the SP papers we recently published, So we look at some part of, the carbon chain distribution of various type of oil collected, in US. And you also did the carbon chain analysis in the field, right? And surprising enough, in majority of the cases, what we found, the distribution in the deposit is being significantly different than what is actually we're seeing on the crude oil, right? And especially for this oil D and Vax C, as you notice, is that in here is that you're seeing some form of carbon chain, which you probably did not see it at all in the crude oil by itself, right? So that is something that we need to actually change the way that we're looking at the problem, than what we used to. And why is that, and what we're missing? There's a lot of factors in here. Definitely, of course, this is the whole distribution of carbon, different carbon chains. Of course, we have a gas phase, we have volatile organic phase, which are looking at C5 to C6 type of carbon chain. And then we have the whole range of other short and low and mid and high molecular weight type of saturates, right? And more specifically, what we have is that the one at the end is that this is actually the piece that we most often overlook. I feel only paying attention to the oil sample, right? And again, back to the things is that when we're sampling it, we need to pay attention to, well, are we really collecting the sample which is most representative what is in the downhole at the time X that we collected the sample, or we don't, right? In that case, that can change the way that we do the designing, our treatments and even recommending the chemistries, right? This is an old one. This is pretty much what you can find in that reference, which I cited in there, This is like a generic melting point as a function of the carbon chain, right? What is interesting enough is that as the carbon chain increases, of course, your melting point goes higher and higher. At least with the calculated C100 is around 250 Fahrenheit, which is significantly high. There's another factor in here, and that's the fact that most of these higher carbon chains or higher paraffins are very less soluble in common solvents and things like that, right? So that is another two elements that you have in that those heavier fractions tends to form faster, and they tend to be unhappy not to be in the solution, long enough, right? And that is something that we need to actually pay attention to, especially if you're looking at that C50 plus or 60 plus type of range. Yeah. So keep that in mind. Let's go to the next. Now, when we treatment, most often what we get is that we collect the samples of the oil, we measure the Vax appearance temperature of the oil, And we assume based on that, wax appearance temperature, assuming the cooling is going to happen, and based on the cooling rate, you're going to start seeing some of the fractions of those paraffin, precipitating out to the point that, sometimes, becomes completely blocking your, pipe, right? So, and that's of course related to what and how much of those paraffins are present there. And of course, we take that information, dialing it into our modeling, tools that we have. There's a lot of softwares out there that you can use it for modeling your flow assurance system, including the Vax. We do a lot of experiments, and again, those experiments are set based on that wax appearance temperature, right? Now, of course, all the asset planning that we do and the development is based on that. And of course, the production operation is a function of that. So you can notice that how that simple, one parameter can impact a lot of things that we do to find out the best solution and best operations of our job, right? Typically what we do for wax appearance temperature, and as we said, we're collecting the sample, from the oil. Then, of course, we applied, multiple different ways. And what that means is that you're looking at what temperature the first crystals are going to form. And of course, we use the methods such as, differential scanning calorimetry of DSC. You get a lot of reports for that. No question on that thing. So sometimes you can go with use cross polarization microscopy and, of course, several other things. We get a number. Okay, that's not bad, right? But what we probably miss is that the fact that, again, the complexity of the crude, as I talked to you about, right? So what we have is that what we need to pay attention to more is that the ratio of the linear to the branch and cyclic alkanes, and that defines actually what that solid organic is behaving. And that's, what temperature and how and what rate is actually a function of this complex type of mixture of different saturates and paraffins that we have in that particular sample. Right? Now, there's definitely, if you're looking at that type of elements, there's a current limitation of the polymeric chemistry. So everything that we have designed, those polymers are basically invented probably from 1970s to 1990s, right? This is a huge, patent actually, patents applied for production of various type of copolymers, and still doing the same thing. And of course, there's a limitation of how we can synthesize those polymers. But in general, people believe that there is a correlation between, the length of that side chain of that copolymer with the way that they are actually interacting with the wax, right? So if you're assuming the wax crystals can also form in the form of the folding one, right? So we're probably looking at 1x to 2x, depending on the side chain lengths that you have that you can control within the polymers, right? Now, with that, in mind, everything that we have so far is that, again, designed for linear form, not much on the branched, or hyper branch paraffins, nor on the cyclic ones, or the combination of the two. And also the fact that with the current existing polymers we have in the market, you can only deal with the carbon chain up to C60. Okay, so keep that magic number, number in your mind, because if you have more than C60, you have to assume that most of the polymers that we have are not going to function as a crystal modifier, things like that, on that type of carbon chain. Okay. Now, the other things that we have is that the composition of the crude oil changes from the day one that they start producing. Sometimes the heavier fraction stays in the reservoir, and what we're producing over the time, we're producing shorter, or lighter hydrocarbons. Sometimes it's actually opposite. The lighter ones are actually produced first because they have higher permeability compared to the, the lower molecular weights have higher permeability compared to the high molecular weight ones. So over the time, your composition is changing towards more heavier fractions. And that's very much what we do see in the kind of a shale type of formations, right? And sometimes that changes is not much, of course that depends on the formation energy too as well. But type 2, as I said, based on my experience, is the one that we see very often, right? Now, the question is that, do you know the history of your crude composition? I'm going to say a lot of cases that I dealt with so far, we don't know, to be honest. We don't do a good job on making sure that tracking down if our composition is changing or not. Because if we don't, that, of course, you can think about our solutions and the way that we're dealing with has to change, yeah? One of the other interesting things that we found lately is that, as you know, we do a lot of the, gas lifting. This is pretty much maybe, 40% of the market, we're using in the market as an artificial lift, you're using some form of a gas lift. And of course, the hydrates are, one of the prime things which happen when you do these gas injections. And of course, what we do, we use a lot of methanol meds and other type of chemistries to control the hydrates formation. And one of the things we found is that those chemistries seems to actually forcing some more wax to fall off from the oil, which was not there before. So if you're seeing something unusual, especially the winter time, they're using a lot of methanol compared to the summertime, this could be associated with that incompatibility, or as we said, induced wax deposition due to the injection of some chemistry that you do. So everything that we do, we need to pay attention to other components which could impact, and interestingly impacting mostly the longer chain compared to the shorter chain. Another interesting thing is that, yes, of course, we have maybe doing mostly type of paraffinic type of crude, but we do have also asphaltene in a lot of cases. And what we found is that, asphaltene and wax can co-precipitate together, what I call it now Vaxphaltene, which is completely new entity, is not neither wax nor asphaltene. And the way we're dealing with the Vaxphaltene has to be completely different than what we do typically deal with the paraffin and the asphaltene only. And we have also published a paper, OTC paper, which dealt about that one, and all typical solvents that we use for asphaltene control can actually, make it worse of what is can deposit in terms of amount of deposition and severity of the deposition can change. And I would definitely love to, point you to read that in an interesting paper to learn more. Now, back to the basic, we still have to do the same thing. We still have to continue, using some form of a chemistry, either continuous or, some form of, a batch type of treatment. But what we are dealing with, definitely we need to pay attention to still to the wax appearance temperature, because, that defines where and how we should deliver the chemistries, either wax crystal modifiers, PPDs, you name it, or, what you name it as a dispersant and solvents, right? So think about that and the factors I told you, the complexity of the system. And we still have to think about our current chemistries are not going to deal with the C60 plus, right? And we need to look for some new chemistries which work around that, either as a crystal modifier or, dispersant whatsoever. But we need to boost the current chemistries that we use, or products that we use, chemical products that we use in this application, by boosting them with some synergies. And, like everybody else, we're working on that now too, yeah? Of course, as you heard, I'm working for the company which we work on the bio-based materials. We do a lot of interesting chemistries in here, including, some which are going after, heavy organics like Vax or Vaxphaltene and asphaltenes. And this is some of the examples of the things that we have done so far. We have taken, of course, things to the field to prove that this concept is working fine, and have the video that I wanted to share with you now is that this is some of the examples that we do. This is sort of a batch treatment. And of course, what we have shown to most of our clients is that the bio-based materials have some interesting properties that they can disperse and mobilize and remove, heavy organics from downhole, either from the pipeline and the other system. So I think, keep looking at stuff that what we do. I think there's a lot of good things happening from this type of area. With that, I'm going to go back to you and open up for the discussion. If you are you up for the new look at your problem? So I would love to hear from you. Thank you.
Thank you, Amir. That's I feel like I've just had a lightning round of education in paraffin that I missed out on at some point in my career. So thank you for that. We've already got our first couple of questions from Danny Durham, who I guess is asking about the scientific basis for a couple of statements you made during the presentation. Are you able to read these, or do you want me to read them for you?
If you go ahead, that would be nice. I don't see that.
So
okay.
he's firstly asked, what's the scientific basis for the comment of the lack of performance of our current treatments on the higher carbon chain waxes?
We have actually worked with the lab in the Midland as well as a joint, work. We look into the best, what is claimed to be the best products out there in terms of the polymers. We look into the specific, actually, as a whole. We did some form of holistic view of we chose a different oil, and especially looking at enriching them with the C60 plus. Actually, we looked at those by using various techniques, including XRT. We look at the particle size distribution. We're looking at deposition type of testing, and we demonstrated very well also together with the DSC type of measurements, as none of those polymers which are actually claimed to be the best in the market did not do anything in terms of reducing the deposition of the C60 plus. And we are presenting a paper, in the Petroface, in a couple of months about that methodology. So it's not, it is actually done, I think, very truly with that. And that's, of course, initiated by a couple of projects that earlier we worked on from the field, that the clients came to us that, the product which was recommended, in the cold finger testing, in the lab testing, showing good, but in the field is not good. As I said, it was a mismatch between what you have to look at and what is actually depositing in the field compared to the lab. Yeah.
So you answered also his second question was, is there any references you can point to? And the answer basically is this is new discovery, so it'll be in the paper that you guys are presenting. You said in 3 months?
In 2 months, yes, exactly, yes. It is, is in the Petroface 2021.
Petroface 2021. Okay, well,
right.
Look forward to that. I think the other surprising finding for me was that, and I guess it's intuitive, but it's not obvious, and that is that if you do a profile of the carbon structures in the oil itself, and then you look at what's depositing, there's going to be a distribution, and obviously it's favoring the higher ends. Is that most common, or is it something that you see more of than you would statistically think is common?
You're right. Of course, definitely most of the field samples are enriched towards higher molecular weight one. But one of the key interesting things we found so far is that most of those gas lift application out there tend to form, more desiccated type of wax. And those ones which are actually moved towards the higher end, some of these we actually, we found out we detected up to C100 type of carbon chain in those deposits. And of course, they are more problematic, compared to what we do. And of course, that comes back to the frequency of the treatment that they need to do in the field. And of course, right now, the only option that client has is to do the solvent treatment very frequently. And of course, that's costly. And of course, has its own.
And you said that those higher chains typically tend to be non-linear and also have higher wax appearance temperatures. So
right.
They're harder to deal with.
Mm-hmm. Yes, indeed.
So John McDonald has a question. For continuous treatment applications, is there precedent for including real-time process measurements? You mentioned heat and flow and temperature to drive the dosing amounts in real time, or is there a need for manual lab work to determine this as opposed to some sort of edge logic device?
Oh, that's definitely a good point. I don't think that we have advanced ourselves too much in terms of doing online or in situ monitoring, unfortunately. I think there's definitely room for new innovation in that area. And even with that, we still there's this huge disconnect between the lab and the field, right? Most of our lab testing has been devoted to the single phase, while what we get from the field is mostly, at least in a multiple phase. And that's what is, again, there is a disconnect. We don't do that much. So still, I think there's definitely room for a lot of improvement and innovation that needs to be done.
Okay. Danny has another question. Is there any papers on this science from Locus Bioenergy at this point, or is it, again, so new you're still to write them?
I think we have a few. We have a couple of papers that we presented in the OTC last year, 2020. We're presenting another 2 this year, 2021, in the OTC, which again is focused on Vax and Asphaltene, or Vaxphaltene, I like to call it nowadays, because I don't think that I really found these are very separated. It's mostly co-precipitated together. And I think the complexity with that one, right? We have also 3 more papers coming later this year with the Oilfield Chemistry one, which hopefully we discuss more. And of course, we wanted to do come back from the field performance data and give it more science by the lab work that we do behind the scene.
Very
good. Hopefully toward this end of this year, we'll have more papers, and I'll be happy to share some of those with Danny.
So, given the experience you've had finding this information out, what advice would you give people right now who are suffering from paraffin problems that they seem to be intractable? What can they do today?
I wish I had a good answer. I hope for that. It's still, I think, well, definitely changing the operational parameter is a key. It's not. I mean, I don't think that chemistry can do everything. Definitely not. Right? Mm-hmm. Chemistry can help. I think some of this will come from the operation, and I think that operation definitely is linked to the method that we use. And I think there's a huge connection with the artificial lift method that we use, right? And of course, the other factor here is that can we really do it? Maybe right now, I don't think that we have that much option for continuous type of treatment, to be honest. But the batch treatment, definitely the way that we can reach out further, deeper into the formation is probably the best option that we would have. So there's some form of intervention that we need to do, right? And I think the one that I show you, that video and things that we do, that's actually right now what we are. We're mostly doing some form of, well intervention, doing batch type of treatment, bullheading some of these chemistry downhole, give it a shut-in period of time, allowing these chemistries to imbibe into the formation and releasing those already deposited Vax, from that formation all the way from tubing out, right?
So while you've said that the molecular weight of the current treatments doesn't match the high molecular weight ends, does more dosing actually give a little bit more effect, or is it completely ineffectual?
What we found from our lab, and again, it of course is the experience of maybe, as I said, the different, of course, every oil is different, right? Mm-hmm. What we found out is that if you go actually increase the dosage, sometimes it could be negative actually impact to you. You can actually induce more because, again, this is the whole about what point they start to crystallize and form, and how they can deposit, and I think I've heard from some of our clients is that they have experienced the same thing, is that the increase actually went up other way around. And you probably have seen it, some of the lab cold finger testing that you've seen actually more deposit forming by applying more ppm of the polymer compared to, so usually you need to do to find out what that optimum is, depending on the crude composition you're dealing with. Very
good. Okay. Well, thank you very much. There's just one last question. Jacob has it, and then we'll have to move to the next session. Jacob says, in our field, we have seen most of our flow line paraffin plugging events after both planned and unplanned downtime. If the well is running, it has no issues. Do you have recommendations for an operational practice type of chemical to mitigate specifically those downtime-related plugging events?
Well, that's definitely an interesting point. A lot of, there's definitely a Reynolds number impact in here, right? There's definitely, the dynamic that we need to pay attention to. Of course, depending on the flow rate, because of that agitation that you get, and that things actually help to remove the Vax. There's no chance, the Vax can precipitate because of the amount of flow rate. I think I have one slide on that one. Let me go to here. And here we go. So definitely is a factor of how fast they are forming, right? And depending on the flow rate, you need to reach out to a condition that they start to deposit. And I'm not surprised that, when you go to static, of course, that you allow these things to agglomerate and, the deposit, right? Mm-hmm. So maybe what you need to do, think about, like what typically people do also on the hydrate. Remember, most of the things that we do in the Gulf of Mexico, we inject, a huge amount of hydrate inhibitor before the hand to shut in, for planned shut in at least, and to prevent when you restart at least there's no problem, right? And that's definitely, you can do that in here. You know, if you have a plant shut in, maybe you apply some form of a chemistries, and probably like a maybe dispersant type of chemistry that will help to prevent this issues, you know, for you. Yeah.
Well, thank you very much, Amir, for your presentation, and thanks everyone who supplied questions. I'd now like everyone to go to the next session, which will be our last session for the day. So thanks again, Amir, and we'll see you on the other side.
Thank you very much for the opportunity. Have a good and safe day, everyone. Bye.